Okay, so now that you've set up the Modella to actually do milling, you're going to want to open a terminal, and you'll see the icon down here. You can just look up how to do that otherwise, but open the terminal, a window like this comes up, and you can open the program in one of two ways. Either you use the tool, which is basically a loader. You just have to type fab, and that will come up with this tool here, and you have to choose the format, which starts from a PNG, and that's what we're going to do. That's what we exported from Eagle, or something that you downloaded from the website. And then you go to the Roland Modella RML down there. And that will start up the make PNG RML program that we want to use. Now you can do that way, or what I prefer is you just type make _PNG _ RML. That's exactly the same way. Exactly the same GUI comes up. So the first thing we're going to do is actually mill the traces. So let's choose that off of the menu at the top here, mill traces, and we're using a 64th end mill, which is what we just placed on the Modella right there. It's the first mill you're going to use. And then we're going to load a PNG. I have mine on an external USB drive, and I'm using the version that I modified, which is FabISP v4.png. That should load it up, and you can see the traces right here in white and the background in black. But now what's going to happen is that it's going to calculate which paths the tool is going to take to leave the copper on one of these copper boards. It's going to etch everything out, but these white traces that are here. So to do that, we have to pay a little bit of attention right here. The diameter of the tool, you can leave that to 0.4. If you have smaller traces or you have gaps that are pretty tiny here between the in between the little pads on the ATtiny on the microcontroller, you might want to go down a little bit. Let's see if 0.4 does the job. Offsets is the number of times the tool is going to go around your path. 4 is a good number. You can probably get away with less, but 4 is a nice number. And then the other thing here that's important is the Z depth. I like to go down a little bit lower to minus 1.1 or 0.1 or 0.12. That basically changes the depth of the bit as it bites into the material. So you don't want to go too low, but it's nice to go deeper. That way you have a nice separation between whatever's left on your copper and the underlying non-conductive material here. So minus 0.12 is a good number. Then you hit the Make Path button, and it's going to go ahead and calculate something here. And you see here that there's a whole bunch of paths, and if you look at the design, you can actually make out the design here. Let's zoom into here a little bit, and you can see that, for example, if you look at here the resonator, which is this 3-lead thing, you can see that the tool is going to be going around each pad, and then it's going to go around. So you can see that there's a nice segregation between these different pads in the way we want. Now let's pay a little bit extra attention right here on this pin. Can you see how these two different pads, this one and that one, are actually connected in the middle? That could potentially be a problem. Now, if we check our design, however, there's this kind of like Y bridge between the two, but these two are meant to be connected anyway, so this is actually not going to be an issue. And if you wanted to get better resolution than just what you have here, you'd have to change the 0.4 millimeter diameter down here. So if we were to do that, let's do that just for fun, go down to, say, 0.25, again, which is not something I'd recommend every day, but let's do it here so you understand. I click Make Path again, and can you see there's more definition now onto the path itself in defining exactly the shape that we have right here. Anyway, so let's go back to 0.4. I just wanted to say that if there are some features like that, for example, these are two connected and they're not supposed to be connected, maybe you need to change the tool diameter a little bit. Now, bear in mind, this is not just something you can go down with no consequences. This is literally the tool diameter. If you are artificially making the tool diameter much tinier than what it actually is in real life, i.e. the bit up there, then that's going to be an issue. So anyway, so all that to say, 0.4 is a good number. In my experience, you can go down to 0.22, 0.25 when your board is very, very dense, but you probably don't need to do that. Alright, so once you've made the path, and we're happy with the path, what you're going to want to do is make the RML file. Now, making the RML file then brings this send it button. Don't click that yet. The first thing we want to do, and this is what we're going to do in the next video, is actually how to zero and start the mill from a set point, a known set point, which is set right here with these values.